This is Geometry, Chapter 15, Lesson 4. We're on page 640. Don't forget to subscribe, smash the like button, and share this video. Okay, volume of a prism. You ready? Volume of a prism. There's a very simple formula for the volume of a prism, all right? And it never changes. The volume of a prism equals big B, which is the area of the base. Remember what I told you about the bases? That's the two shapes that are congruent. Okay? It's the area of the base times the height, which is often referred to as the altitude. It's just whatever the area of the base is times the height. If it's the volume of a rectangular prism, what is that going to be? What is the base going to be? It's just length times width, that's going to be the base, times height. All right, what about the volume of a triangular prism? What is it going to be?
Length times width over
Half.
Yeah, half little b times height, that's the area of the base, right? Times the height of the prism. Okay? What would be the volume if it had a circular base, a circular prism? So it was,
R squared.
pi r squared
pi, Paula, r squared
times the height.
times the height. You get the idea,
Yes,
right? What if
No. I'm running it fast. Thank you.
What if, I'll go over here, I have room over here. What if it, what would be the volume of a regular pentagonal prism?
Maybe Mr. Squared times the height.
It would be Mr. Squared times the height. Yes. You got it?
What are those words?
What does M stand for?
Oh, well,
The area
Number of sides
times
sine of 180 over n times the cosine of
times whatever the radius squared is times the height.
what does that look like?
You had like a
Like a
pentagon that would be
Okay, what does that look like? Of course, you're asking me to draw that. My goodness gracious.
Wait, isn't Mr. Squared? Oh. I'm
45?
squared times the height.
Okay,
Gotcha.
do you see this?
Oh. Okay.
It's like a house.
Yeah, that's probably not the right dotted lines or
So
the
it's
right
just like
solid lines, but
regular.
you get the idea, right?
Totally.
Okay, now, what is this height or the altitude? The height or the altitude is a perpendicular line between the bases. So look at this triangular. All right, this really is flat, but I have to draw it this way because it's on the board, but you get it, it's this way. So it would be a perpendicular line between the bases. Because that's oblique. It's not the length of the side, it's a perpendicular altitude to both of the bases. Got it? I would go perpendicularly through this. Right?
Oh.
It would actually be sitting like this, right? But the height would be the distance between my fingers, not the length of the
So
side.
how do you find that?
It will either be given, or could I not use right triangles potentially? Got it? Like
so there
if
isn't
I,
like a special way to figure it out.
well, either it's going to be given, or you're going to be able to use right triangles. You got it? All right. Here's what you need to remember. This is why I make a deal about this. The altitude is not necessarily the length of a side. The only time the altitude is the length of a side is if it is a right prism. Okay? So the altitude would be this, or even the length of the edge, right? Because that's perpendicular. The bases are perpendicular to one another. When it's oblique, it's not the length of the side. Got it? That's too long. All right? Now, let's talk about what a cross section is. Yes, ma'am.
So is it like a triangle and like a square, rectangle, a regular pentagon? I'm not a pentagon. Oh, that's
A square is regular. A square is
Did
regular.
I say polygon or pen?
Pentagonal. So it's a pentagon.
Okay, never mind. I thought it.
Got it?
Polygon.
Okay. What does the word cross section mean? Cross section simply means if I have these 4 bars of candy, okay, y'all can see them? All right. This is the Butterfinger, this is the Snickers, this is the Milky Way, this is the Three Musketeers. Got it? A cross section, can y'all see? A cross section says, if I let's just take the Three Musketeer, and if I cut it,
Beautiful.
so that is a plane intersect, like the knife is a plane intersecting the solid, then what shape do I have? And it's
Square. The base.
this probably is a rectangle, right?
That's what I meant.
The cross section would be a rectangle. Got it?
It would be the same as the base.
Yes.
Okay.
Because what if you cut the square?
This is the word I'm trying to explain what the word cross section means. Got it?
That was a good demonstration.
Okay. Now, what if, let's assume, ladies and gentlemen, let's assume that the Milky Way and the Three Musketeers, let's assume that their bases are exactly the same, have the same area. So their length is the same area as their height. If the bases are the same and I intersect these planes such that
Sticky little
yeah, sticky, yeah. Such that their bases are the same, right? I don't know if this is gonna work. And they can exist between 2 planes that are parallel. Got it? Then their volumes are equal. That's Cavalieri's principle. All right, so I'm going to say those words. Got it? A cross section just simply says I intersect a solid with a plane, and what shape do I see when I pull them apart? Got it? That's cross section. All right. If I take two cross sections and their bases have the same area, and I can lie those two solids between parallel planes, then their volumes are equal. You got it? Look at Cavalieri's principle under postulate 13. Here's where the bases are not the same. One is triangular, and one, is it square or rectangular? It's rectangular, all right? If the area of the triangle is the same as the area of the rectangle, so 1/2 base times height is equivalent to base times height in the rectangle, and I cut a cross section out of those solids such that they can lie between parallel planes, then their volumes are the same.
Wait, so these two are, the volumes are like equal?
Which two?
The triangle and
Okay, if I said, all right, everybody listen. If the base of the triangle, which is 1/2 base times height, is equal to the base of the rectangle, which is length times width. If those two areas are equivalent, right? If the bases are equal, and I place a cross section of each of them between parallel lines, then their volumes are going to be equal. Yes, that's
How do
Cavalieri's
you
principle.
prove it? Like,
You do the math.
well, with the parallel, like,
Well, you would have to know they're parallel.
okay, so it's saying that
It would be given.
the height is basically the same.
No,
and
I
those
cut it. I cut it, right? The height may not originally be the same, but in the end, when I take a cross section, I cut it such that these can lie between parallel planes.
Okay.
Then the volume is equal. Yes.
So like if you had two like bars and then one of them was like longer than the other one, but they were still the same size, and then you just like cut them evenly, then they were the same.
Exactly. Yes.
Okay.
Yeah. And so we have that, right? We have a Snickers, and then we have the Three Musketeers, right? If the bases are the same, if length times width is the same, and I cut this such that this could lie between a parallel plane, right? I'd have to cut it here and here. Chocolate gives you the hiccups. Just kidding. Okay. Then the areas would be, the volumes would be the same. All right? Now, I have a question. All right? We have Butterfingers, Snickers, a Milky Way, and a Three Musketeer. I don't have whole bars now. Okay. Which one, what is the difference between volume and mass?
Wait.
Difference between volume and mass. Yes.
is it?
We learned this last year.
It does have to do with density. Yes.
much
Doesn't
is
mass have something to do with like the
Yes. It's how much is packed in on the inside. It's almost like how much it weighs. Is it heavier? Does it have more dense?
like the polar gravity?
No. Well, you would look at it in the absence of gravity. Typically, you look at mass in the now we can look at mass considering gravity definitely affects mass.
Isn't it like if you have a bowling ball or something?
Yes.
And then like
Compared to
the- compared to
keep going. If you have a bowling ball,
No, I was just saying like isn't it different if you were like on the moon, like the mass is different but the volume is the same?
correct.
Oh, so never mind.
Okay, so if I'm just looking at the Three Musketeers, the Snickers, and a Butterfinger and a Milky Way, let's say their volumes are all the same. Which one would have greater mass of those 4 candy bars?
The Butterfinger compared to the Musketeer.
Yeah. I almost would say the Snickers bar.
Okay.
Yeah.
Or Butterfinger.
It would be one of the two, right? So what is volume? What?
How much of the prism is being taken up?
Yes, how much space that prism occupies. Exactly. How much space that prism occupies. Whereas mass has to do more with what's in the middle.
Oh,
Got it?
yeah.
All right.